This is AP Calculus AB. We're doing Notes, Section 1.1, Understanding a Limit, a Numerical and Graphical Approach. The equation of the function graph to the right, it's actually graphed down here. Vertical, horizontal asymptote, it's got a couple curves, it's got a hole in it. Is f of x equals 2x squared plus 5x minus 3 over x squared minus 9er. The coordinates of the hole are here. Let me refresh your memory of how we could find the coordinates of this hole, as well as the vertical and horizontal asymptotes. As far as the horizontal asymptote is concerned, if you remember, you compare the growth rate of the top and the bottom. They're both growing by x squared. Since they're growing the same, since the exponents are the same here, you divide the lead coefficients. So this would have a horizontal asymptote at y equals 2 over 1, which is 2. If you look at the graph down below in your paper, you will see that that's true. To find the vertical asymptote in the holes, we would want to factor this function. The numerator factors into 2x minus 1 and x plus 3. The denominator factors into the difference of two squares, x minus 3 and x plus 3. If you forget how to factor trinomials, check out some of the lessons from pre-calc that we've done in the past and review that. From here, when things cancel, remember what happens when things cancel? It means we're going to have a hole. So this graph is going to have a hole at x equals negative 3. That's because our canceled term, our canceled factor, if you set it equal to 0 and solve it, we have a hole at x equals negative 3. To find the y value of that hole, which sometimes is important, sometimes it isn't, we take what's left of the function, which is f of x equals 2x minus 1 over x minus 3. And you take this negative 3 and you plug it into the top and the bottom. If you plug it into the top, 2 times negative 3 is negative 6, minus 1 is negative 7. If you plug it into the bottom, negative 3 minus 3 is a negative 6. That's going to make this 7, 6. So the coordinates of the hole are negative 3 and 7, 6. Now, they told us that at the beginning. I'm just reviewing with you how you find holes. To find the vertical asymptote, you take any uncanceled factors in the denominator, you set it equal to 0 and solve it. So we would set x minus 3 equal to 0. So that means vertical asymptote at x equals 3. To find the zeros of the function, you take any uncanceled factor in the numerator, set it equal to 0 and solve it, and you're going to find that's 1/2. Yes, and then to find the y-intercept, this is all review, we take the coefficients, no, I'm sorry, the constants in the function, and we divide them. That could happen here and get 1/3. It could happen also here and get 1/3. Let's just check out our graph. We're just going to bring some of this information down just to confirm that all this stuff is true. So is there a horizontal asymptote at 2? Sure is. Is there a vertical one at x equals 3? You betcha. Is there 0 and x-intercept at 1/2? Sure looks like it could be. Is there a y-intercept of 1/3? Looks like it could be. So also there's a hole at negative 3, 7, 6. That also looks like it could be true. So that's just a review of where these things come from. Now when we get into limits, which we've discussed before, let's review what a limit is. This is saying to make a conjecture. I'll just tell you what it is, and then we'll look at the graph. So first of all, limit notation. The limit of a function as x approaches some number. What this means is it's the y value, the graph approaches, that word's important, as x gets closer to a, as x approaches a. So if we look back at this graph, as x goes to negative infinity, what does y get closer to? If we follow this graph, as x goes to the left forever, looks like this curve, the y value, is getting closer and closer to the horizontal asymptote of 2. What's the limit of f of x as x approaches positive infinity? If we follow the curve to the right forever, it's getting closer and closer to this horizontal asymptote of 2. What's the limit of f of x as x approaches negative 3? Remember this symbol here, it means from the left. So here's negative 3. If we approach from the left, that means we're actually moving to the right. As we approach from the left, the y value is getting closer and closer to the value of that hole, which is 7, 6. What's the limit of f of x as x approaches negative 3 from the right? If you approach negative 3 from the right, we're also approaching this hole, and the y value of that hole is 7, 6. What's the limit of f of x as x approaches positive 3 from the left? Well, here's positive 3. If we approach from the left, looks like the y values are going down forever, so it's approaching negative infinity. What's the limit of f of x as x approaches 3 from the right? It's approaching positive infinity. Calculus is the study of limits. It is the study of slopes. Through limits and slopes, we will be studying everything that we need to study about calculus. Now, an important note. The limit as x approaches, let's say, negative 3 of f of x does not necessarily mean what is the function evaluated at negative 3. This is a y value that it is equal to. This is a y value that it's approaching. As an example, what is the y value when x is negative 3? There is no y value, there's a hole there. So this does not exist. What is the limit of f of x as x approaches negative 3 from the left and from the right? Well, it's approaching the same number of 7, 6. This does exist. So I just want to make a point, once again, this is what y is approaching. This is what y is equal to. Could these be the same numbers? Yes, they could, but they don't have to. Oh, our first theorem. Exciting stuff. The limit existence theorem. The limit of f of x as x approaches a exists if and only if, means we can read this forwards or backwards, if the limit of f of x as x approaches a from the left is equal to the limit of f of x as x approaches a from the right, if those both equal the same number, and that number is a real number. So for example, if this was an infinity symbol, the limit doesn't exist because infinity is not a number. The left and right-sided limits have to agree for the two-sided limit to exist. This two-sided limit, this is a one-sided limit, this is a one-sided limit. One-sided, you approach from the left or the right. Two-sided limit, you approach from both sides. In general, we don't call a two-sided limit a two-sided limit, we just call it a limit. But we specifically call a one-sided limit a one-sided limit. Let's check out example 1. Find each of the following from the graph. Example number 1. A, find the limit of f of x as x approaches 2 from the left. So what it's asking, What does y get closer to as x gets closer to 2 from the left? As we approach 2 from the left, y is going up forever, it's approaching infinity. What's the limit of f of x as x approaches 2 from the right? If you approach 2 from the right, it's also approaching infinity. According to the limit, well, we won't get into that yet. Sorry. What is f of 2? What's the y value when x is 2? There is no y value. It does not exist. Question D, excuse me. Does the limit of f of x as x approaches 2, this is the two-sided limit, does it exist or not? Well, it looks like it would exist. They're both approaching the same thing, but that thing has to be a real number. Infinity is not a real number. So we would say, in calculus, you must justify everything that you do on a free response question. So we would say no. The limit of f of x as x approaches 2 equals infinity, which is not a number. So there's a reason. Number 2, see what's happening here. The limit of f of x as x approaches 2 from the left, so it's 2 again. As we approach 2 from the left and we get closer and closer to it, we're not trying to get to 2, we're trying to get closer to it. It looks like the y value is getting closer and closer to positive 2. Could be a little bit less than that, we are estimating. What's the limit of f of x as x approaches 2 from the right? As we approach from the right, we're approaching 2 from the right, we're getting closer and closer to the y value of this hole, which we have estimated is 2. What is f of 2? Well, if you go on the graph, when x is 2, the y value appears to be -3 or something close to it. Does this limit exist? Well, according to the limit existence theorem, this limit does exist because the left and right-sided limits agree, and they agree to be a number. So we would say yes. Because, well, let me not say that. Yes, the limit of f of x as x approaches 2 exists because the limit of f of x as x approaches 2 from the left is equal to the limit of f of x as x approaches 2 from the right, which is 2. Notice, for a limit to exist, the left and right limits have to agree, but the function evaluated at the y value doesn't have to agree. Notice these two are both 2, and this one's not a 2. It's a different number. The limit still exists. Check out example 3. Find the limit of f of x as x approaches 2 from the left. Looks like y is approaching 3 from the left. If we approach from the right, looks like it's approaching -3. What is the value of the function, it's the y value, when x is 2? Well, when x is 2, the value of the function is 3. Does this limit exist? No. The limit of f of x as x approaches 2 does not exist because the limit as x approaches 2 from the left does not equal I think I'm writing it a little too large for the space that I have. Okay. The limit of f of x as x approaches 2 from the right. They are approaching different numbers, 3 in one case and -3 in another. Let's do some flipping. Based on what you've seen so far, does f of a have to be defined in order for the limit of f of x as x approaches a to exist? Draw and explain two different graphs to justify your reasoning. In both graphs, well, let's first answer this question. Does it have to be defined in order for it to exist? We would say no, because if we look at this problem here, actually, we weren't given any examples like that. So let me tell you it's no, and I'll give you my reasons. So we just can't say no, because that's a Bush League. F of A does not need to be defined for the limit of f of x as x approaches a to exist. Next part, draw and explain two different graphs to justify reasoning. In both graphs, f of a should be undefined, but in one graph the limit should exist, while in the second one it should not exist. So let me do that. I draw an x and y axis. Let me draw an x and y axis. In this first case, I'm going to put a here. The second case, I'm going to put a in the same location. So we got some random curve that goes through this hole and then continues. And over here, I'm going to have some random curve that goes through this endpoint, and then I'm going to have above that like a piecewise function like so. So in both cases, we were supposed to f of a, in both graphs, f of a should be undefined. All right, I didn't do this one right then. Open circle. And the limit should exist, while in the second one it should not exist. In one graph the limit should exist, the other one that it shouldn't. So in this first one, f of x is undefined. I should say f of a is undefined. But the limit of f of x as x approaches a does exist. By the way, x equals a is a point of discontinuity. Discontinuity is an important concept in calculus. In the second graph, we could say, well, f of a is undefined. And the limit of f of x as x approaches a doesn't exist. In this case, x equals a is a jump discontinuity. Let me rephrase this first one. X equals a is, let's just say, point discontinuity. Removable discontinuity was another term that we use for point discontinuity. And the second one, x equals a, is the jump discontinuity. So the question is, does the function existing at a number determine whether the limit exists or not? And the answer is no. So I would say, yeah, let me not say that. We're almost done here. We just got to look at some tables and then some graphs. Below is a table of values of an exponential function. Use the table to find the limits that follow. Just a quick reminder, an exponential function is a function that either looks like this, exponential growth, like this, exponential decay, or it could be flipped this way, or it could be flipped, what's left here? Because another choice, like this. Could be one of those four things. Quick review. So if we look at this table, as we go to the right, looks like it's getting closer to a horizontal asymptote. As we go to the left, looks like it's getting bigger and bigger and bigger. So remember this stuff from pre-calc. If we are approaching, if we're going to the right and it's approaching a number, then we're saying that it's growing or decaying with bound, which is not really relevant here, but just mentioning. Anywho, well, I tell you what, let's write some of this down. I am saying right now that if we go to the right forever, well, I'm sorry, I won't say that. Let's just jump to the questions. What's the limit of f of x as x approaches negative infinity? As we move to the left, which is what this is saying, the y values are getting bigger and bigger and bigger. They're growing without bound. It's unbounded. It's going to infinity. Let's do this one here next. What's the limit of f of x as x approaches positive infinity? As we move to the right, it looks like these numbers are growing and they are bounded by whatever this horizontal asymptote is, and it sure looks like it's 1. And we don't know if it's 1 for sure, but we're guessing that it's 1 or something close to 1. What's the limit of f of x as x approaches negative 3? Well, we know that an exponential function is continuous. There are no holes in the graph. So if we approach negative 3 from the left or from the right, it's going to be also approaching this y value of whatever that point is, which is 9. So we would say that that is 9. What happens if we approach 1 from the left and the right? Well, if we approach from the right, it's getting closer to 1.5. If we approach, that's the left. If we approach from the right, it's getting closer to 1.5. So we would say that's just 1.5. Long story short, if it's a continuous function, you want to know what the limit is as it approaches a number. Well, it's just whatever the y value is. Below is the table of values for a rational function. So a rational function could have holes in it, and it could have vertical asymptotes. Use the table to find the limits that follow. So what's the limit of f of x as x approaches negative infinity? As we go left forever, what's happening to the y values? Well, notice how these x values are jumping around a lot. At negative 1,000, we're at 1.02. Looks like to me this is going to be approaching a horizontal asymptote of 1, which happens in rational functions. Let's go to the positive infinity one. If we go to the right forever, it looks like this is also getting closer to 1. Could it be 0.99 repeating? Sure. Like we are guessing, but 1 seems reasonable. What's the limit of f of x as x approaches negative 1 from the left? Now, negative 1 is undefined, but if we approach from the left, it looks like this number is getting pretty big. I would say that's approaching positive infinity. What happens if we approach negative 1 from the right? It looks like this number is also getting pretty big from the right, but it's approaching negative infinity. Let me tell you what that would mean graphically. It means we have a vertical asymptote at x equals negative 1. If we approach from the left, it's going to infinity, so that means it's increasing like so. If we approach from the right, it's approaching negative infinity, so it might look something like this. All right, so D, x is approaching 2. Well, this is a two-sided limit. As x approaches 2 from the right, it looks like the y value is getting closer to like maybe a third, 0.3 repeating. I think I said that wrong. As x approaches 2 from the left, it's approaching 0.3 repeating. As we approach from the right, it sure looks like this is a very similar number to this. So I think we could agree that this is approaching a third, or 0.3 repeating. Since this is undefined, that must mean that there's a hole in the graph here. We've already determined this is a vertical asymptote. What's the limit of f of x as x approaches negative 1? Well, if we, here's negative 1 over here. To answer this, we don't have to look at this table at all. We just look at these two answers. Do they agree, first of all? No, they don't, so it doesn't exist. If they do agree, but if they're not a number, then we could also say it doesn't exist. Graphical analysis of limits. Use the graph to find the limits, and if a limit doesn't exist, state why. So A, we're supposed to find what the y value is approaching as x approaches negative 3 from the left. Negative 3 is here. If we approach from the left, it looks like y is approaching infinity, which means the limit does not exist because infinity is not a number. B, what's the limit of f of x as x approaches negative 5? This is a two-sided limit. So if you approach from the left or the right, they're both approaching the same point. They're both approaching a y value of 4. So we would simply say that's 4. Some students struggle with this because they think, well, this point's down here. We're not trying to get to x value of negative 5. We're trying to get close to it. What's the limit of f of x as x approaches negative 1? Well, here's negative 1. If you approach from the left or the right, it's approaching negative 1. C, which is Spanish for yes. If you approach negative 3 from the left, it's approaching infinity. From the right, it's approaching negative infinity. So it does not exist. A couple different reasons you could give for this. One, we could just say the limit of f of x as x approaches negative 3 from the left does not equal the limit of f of x as x approaches negative 3 from the right. D, what's the limit as x approaches 2 from the left? Here's positive 2. If you approach from the left, it's approaching this y value of 1. What happens if you approach 2 from the right? If you approach 2 from the right, y is getting closer to positive 6. Question F, you don't need the graph. You got the left and the right here. Are these the same numbers? They are not. So we would say for this, does not exist. Reason, the limit of f of x as x approaches 2 from the left does not equal the limit of f of x as x approaches 2 from the right. G, what's the limit as x approaches negative infinity? As we go left forever, this curve's getting closer and closer to this horizontal asymptote of 2. And as we go right forever, the y value is growing without bound. So we would say this is going to infinity, which means this limit does not exist. Infinity does not equal a number. Please stop this video, pause it, and do this problem on your own. And then when you're done, check your answers. And we're back. I got 0 for this, -4, 2, 0, negative infinity, does not exist because the limit of g of x as x approaches 4 from the left does not equal the limit as x approaches 4 from the right. And I got -2 for this, and I got -6 for this one. Let me just look at the graphs real quick to make sure those are right. As x approaches -3 from the left, y is getting closer to 0. I agree. This one below it, as x approaches -3 from the right, it's getting closer to 0. I agree. As x approaches -6 from the left and the right, it's approaching -4. As x approaches -1 from the right, here's -1. It's approaching this maximum value of 2. As x approaches 4 from the left and from the right, so here's 4 from the left. I don't agree with what I have there from the left. Yeah, I don't agree with that at all. This graph just does not approach from the left. Like, it does not get close to it. It just stops here at 3. So for this one, I'm going to change to just straight up does not exist. Reason for that would be difficult for me to write a reason. From the right, it's approaching from the right. It's going to -infinity. I agree. And then this, those don't agree, so that's why that's happening. Yeah, that's right. And then here, x is approaching -4 from the right. Y is getting closer to -2. X is approaching -4 from the left. Y is getting closer to -6. There you go. Hopefully that made some sense to you. A lot of similar concepts from what we did from last year. Please do the